What a performance. Everyone should be dancing now, right? So let's come back to our participants. Next up, we have Federica Maestri, who won the prestigious Weizmann Summer Academy with her project last year. Let's see what she has in store for us this year. Go ahead, Federica. Show us what you got.
Good afternoon. My name is Federica, and today I would like to walk you through my research about machine learning's role in breast cancer prediction and factors influencing trust in AI. So, breast cancer is the leading cause of death in women and the most common type of cancer. The best preventing tool at the moment are screening tests, but due to the COVID-19 pandemic, mammograms rates have dropped about 80%. Resulting in 2,487 projected deaths by 2030 only in the US. And these projections, unfortunately, are only hypothetical because more and more women start presenting no symptoms. So my research question was to identify what are the possible key factors, factors linked to the development of breast cancer, and to what extent can machine learning effectively predict the onset of the disease while ensuring trust in the results. So there are different risk factors that have been linked with the onset of breast cancer. Some of them are being a woman. Only 1% of cases are men. Age, ethnicity, genetic mutations. For instance, BRCA1, BRCA2, CHEK2 mutations represent between a 28 to 37% risk increase. Having a child, having a history of breast cancer. These are all risk factors that cannot be modifiable. However, there are some that can, and are all the lifestyle-related ones. However, it is too ambitious and arguably hazardous to think that if all women change their habits, then breast cancer rates would go down. So how can machine learning help in breast cancer detection? We can acquire an image. We can, let's say, extract the features that are more important. And this will generate a vector whose components are the extracted features. And eventually, we will get a trained machine learning model. Once the machine learning model can effectively predict, predictably classify the images of a blind set, which is called the testing set, then we can assess the classification performance. And this is done by building a confusion matrix and by outlining 4 different factors, which are the true positive, true negative, false positive, and false negative values. There are also different metrics to assess the performance. This one behind me, it's the UC ROC curve, and it's one of them. When it comes to the website that I decided to create, the goal was to develop something that all women around the world, no matter their country, GDP, or their social economic status, can access from a phone or a laptop and have a chance to reflect on their medical history and eventually seek the advice of an healthcare provider. So here's the design of the website. We have 2 different buttons. The first one links to a risk assessment tool in a sort of questionnaire, and the second one is machine learning based. So if we click on the first button, we will access the questionnaire. So there are different questions. For instance, before I said that for CHEK2 mutations, we have a risk between 28 to 37% increase. So what I did, I calculated the average, and I assigned to each question a weight. If the questionnaire is not completely filled, an exception will be raised so that the risk can be assessed. There's no scientific evidence stating that the risk is cumulative, so meaning that we can add all these percentages together. So that's why they're shown per category. We can further analyze the results by via some statistical graphics that show general trends in breast cancer related to age, ethnicity, and genetic mutations. All the lifetime risks are explained, and this is important because it gives transparency to the model we are trying to build. The second one, instead, it's machine learning based. So the training set that I've used contains information on cell nuclei obtained from digitalized images of a small mass of breast cancer tissue. So these values can be either generated or input, and if they are not all inputted, an exception will be raised. But once it's completely filled, we can predict the probability, and in this case, it was 0.59. The second part of the project revolved around measuring and establishing trust in deep learning. So there are different factors that can influence the trust in AI. So we have the type of algorithm, we have characteristics like the accountability or complexity of the model, we have the lack of common sense because AI, it's unable to recognize obvious fallacies that human can easily see. We have problems in the generalization, for instance, of AI, and also the users themselves can represent a limiting factor because they bring to the table their past experiences, their education, their own views and biases. So is it important to maximize the user's trust? No, because when trust is at the maximum, the user will believe anything that the AI will recommend, and therefore it does not result in the best AI-human collaboration. So what I wanted to try and do by building a neural network was to, we have seen a breast cancer risk assessment tool with questions. We have seen one with numerical inputs, but why don't we just input a mammogram and build a model that will output us the result through an image? So the goal was not only to deploy the system, but also to implement it without using any built-in functions. This is the structure of the neural network. There are 2 hidden layers, and this is more or less the data set that I've used. It contains 7,632 images that were all resized to 227 pixels. And this is how it looks like when running the model. So the cost is printed after every 100 iteration. And the cost function, basically, it measures the difference, so the error between the output and the predicted value. So the more, the better the model is learning, the more the function should decrease. And when a minimum is reached, it means that the model is as accurate as it can be for the given training data. So when looking at the finished projects, there were different challenges, not only due to the black box nature of algorithm, but also to the different risk factors related to breast cancer. And this shows not only that there are some studies that need to be done, but not only to increase the biological understanding of the disease, but also to build more helpful and reliable digital resources. So AI will not replace radiologists, but it can add as a value-added tool. And so to conclude, we need to combine the medical expertise of the medical personnel, so their intuition, their analysis, together with the computational power of AI, because there is significant potential and it's key. Thank you.
Federica, nice to see you again. Really, really happy to see you again here because, I was just saying, you won one of the best prizes last year. You went to the Weizmann Institute. Can you tell us a tiny bit more about it before we plunge into your new project here?
Yes, it was really nice. We were all divided in 4 different groups.
Yes.
Mine worked on RNA specifically for glioblastoma, which is brain cancer. It was really nice because we did not only combine, let's say, the biology behind the disease, but also the bioinformatics part, so analysis of data.
Oh, that's spot on here, isn't it?
Yeah.
Yes.
So it was really nice. I had the chance of meeting many interesting people. And of course, also the professors and the academics that work at the Weizmann.
There was just one tiny downfall. It was online though this year because
Yes.
still of constraints, and but you could still take something out of it.
Yes, no, it was really nice. We still did organize some also social activities apart from the.
I saw that.
Yeah, so it was nice. I really hope the people that are gonna be getting the award this year are gonna go to Israel because I feel like it's really nice.
Surprised because I was following you closely about the activities that you were doing there. I also you saw that you got involved, for example, during the book year, the yearbook with all the nicknames of the people, and we could really see that despite the fact that it was online, people had interactions and had time to develop relationships with one another and nicknames and things like that. So
yes,
that made us really, really happy about that. Yeah.
So yes, can you tell us a little bit about the project? You mentioned before breast cancer, using machine learning algorithms to detect it or prevent it.
Yeah, so the goal was to first analyze the risk factors that are involved with the onset of breast cancer. And then I used these values to build a website, a risk assessment tool, which is a questionnaire. So I assigned a weight to each question. I feel like the most important part is that all women around the world, no matter their country GDP or their social economic status, they can easily access it from a phone or a laptop. And the second one instead was a machine learning model based on numerical inputs. And the last one was a neural network using deep learning, and that one used images. So we input an image, a mammogram, and we output if it's a benign or malignant cancer.
Amazing. I love it.
Yeah, there are a lot of steps in that project. We can see that you said that you worked 1 year on it.
Yeah.
Obviously, like I would have thought 5 years personally. But what was the most difficult part for you in all those different steps here?
I feel like it was the learning, because I did not have, for instance, I did not have any knowledge in machine learning or deep neural networks. So there was a lot of learning that had to be done behind the curtains to then, be able to implement these models.
Yes, it's obviously like a really, really hot topic at the moment, and more people are using machine learning, like artificial intelligence, especially for picture analysis. I also saw, for example, last week, there was a study that showed that they analyzed pictures of cancers and trying to spot them for skin cancer, and they realized that by showing pictures where there was a ruler, each time the artificial intelligence identified the ruler as a potential risk for cancer. So it's a lot of downfalls, and there is a lot to learn in there. What was your major take out of all of that?
So I truly believe that the world's sustainability will strongly depend on the importance that we will give to new scientific breakthroughs. But AI is not all perfect. It sometimes can reinforce and the effects, for example, of human biases, societal discrimination. So there is a lot that has to be done, and the key is to take, not only computer scientists, but also like engineers, doctors, all working together for the same goal. So yes, the most complicated part is, try to learn a bit of everything to then be able to do it correctly. There are a lot of issues right now also with transparency in AI, can the user understand what the model is doing, we don't want to predict something.
The black box, yeah.
Yes, exactly, the black box nature of algorithms.
But sorry?
I have a technical question about the data for training. Sometimes it's difficult to find data.
Yes.
You had access to the data?
Yeah, I found an open source online, but there are so many concerns right now also because, on a such bigger, more level, countries don't share data between themselves. So you might have the same, a different group of people that are working on the same project in different parts of the world that do not collaborate, while they could be making so much more progress if they just share data.
Totally.
Yeah.
But you're really a good example for us because you are pushing all those problems with pluridisciplinary. Sorry, you call it.
Yeah.
And we realize with the projects that year after year that they become more and more complex. They go more and more deeper, and it requires people to work together usually, and then from different fields. And so you're good. Just to say that you're a good example for everyone here. So
yes. Thank you.
Yes, amazing work.
Are you coming back next year? You might have reached the age limit, right?
No, I think next year I can still participate.
Perfect. That sounds all fine to me here. You can sing right out the door here. But yeah, so you will be able to explain more about your project tomorrow for the public here because we have the exhibition here. We are really, really happy to see you again here. And
Thank you,
it's just beginning here now. So thanks a lot for everything.
Thank you so much.
Thank you.